Hi girls, in this video I'll take you through some of the questions as found in the level 3 paper, chemistry 3.4, which is the thermochemical principles paper, and this is the NCEA end of year exam paper from 2013. If you want to have a look at the paper, I've uploaded it to Ultranet, so you can take the question from there as well. So the first one that I'll be helping you answer today is question 1b. You'll find this on page 2 in the 2013 paper. The question is very simple. It says, discuss the data for each of the following pairs of particles. And the pair is, for this particular question, for Roman number 1, you have a pair that is oxygen and selenium. And the periodic trend that they're going to look at is electronegativity. So oxygen has an electronegativity of 3.44 and selenium has an electronegativity value of 2.55. So your question is, discuss. You're going to tell them why selenium has a lower electronegativity when compared to oxygen. So a few things to recall is, what is electronegativity? Okay. Electronegativity is a measure of the tendency of an atom to attract electrons in a bond to itself. Now, it's always good, I've told you this, to have a definition memorized. You may have to write it. Sometimes they do ask you a question, what is electronegativity? Then look up your continuing chemistry textbook and learn the definition. So it is the ability to attract electrons in a bond to the nucleus of its own atom. We also know that there is a trend in the electronegativity in where it increases as you go from bottom to the top, and it also increases as you go from left to right, which makes fluorine the most electronegative element. But we're not looking at fluorine. Our focus is on oxygen, which is right there, and selenium there. You notice that what is similar between these two is that they are both in group 16. Now, if they're both in group 16, that means they have 6 valence electrons in their outermost shell. Okay, so that's what's similar between them. But what is different? What is different is that oxygen is in this period, which is period number 2. And in this period, you know that it's the second energy level that's being filled as you go from left to right. Whereas selenium is in period, that's period 4. So for selenium, you have the first energy level completely filled, the second one completely filled, the third completely filled, and the fourth is being filled as you go from left to right. So you notice the valence electrons are actually further away from the nucleus as compared to oxygen. Okay, so then let's look at how we'll structure our answer. How do you now explain why selenium has a lower electronegativity value as compared to oxygen? So when you're answering, you keep this format, and that will help you discuss the arrangement of electrons first. So I've said here that Se, which is just selenium, is in period 4 and has valence electrons in energy levels that are further from the nucleus than oxygen, which is in period 2 and has its valence electrons closer to the nucleus. So what happens because of that? So then go on to, how does that affect electronegativity? So I've said that because its valence electrons are in energy levels that are further from the nucleus, there is increased shielding from the inner shells. Okay, now come back and connect to the context given in this question, and the context is, why does selenium have a lower electronegativity? So you always finish your answer by connecting to the context in the question. So it says, this means there are weaker electrostatic attractions between the nucleus and the bonded electrons or the valence electrons, and so selenium has a lower electronegativity than oxygen. So your keywords for this answer is the fact that it has electrons and energy levels that are further from the nucleus. There's increased shielding because of that, and the fact that there's a weaker electrostatic attraction. So those are your 3 keywords, and then you always end it by connecting back to the question and saying, so selenium has a lower electronegativity than oxygen. Okay, so we'll move on to this same question 1, but there's another part to it. So the same question 1, but we're looking at B, and it's 2, Roman number 2 this time. So the question is the same. Discuss the data for each of the following pairs of particles. So the previous pair, the question related to electronegativity. For this pair, the question relates to radii or radius. And they have given you the radius of the chlorine atom, which is 99, and the chloride ion, which is 181 and is larger. So they want you to discuss why the radius of the negative ion is larger than the radius of the atom. So if you go back and look at your definition, I've taken the definition from page 77 of Continuing Chemistry. It says the ionic radius of a positive ion is smaller than the corresponding atom. So if it's a positive ion, it's going to be smaller than the corresponding atom because the entire valence shell has been removed. The more positive the ion, the smaller it is. For the same reason, the atoms are smaller going across the period. We don't want this bit here because we are actually looking at a negative ion. So we actually start reading from here. The ionic radius of a negative ion is greater than the corresponding atom. As more electrons are added to the valence shell, they repel. So your key idea here is repulsion. And the other idea is the keyword effective nuclear charge remains the same. That means there is no change to the number of protons and their charge inside the nucleus. And so the key word for that is effective nuclear charge. Remains the same, so the ionic radius increases. The greater the negative charge on the ion, the more the repulsion and larger the radius. So the two key ideas is when you have a negative ion, you're adding electrons, so you increase the repulsion because you're adding it into the same valence shell. The effective nuclear charge doesn't change, it is still the same. So because of the repulsion, the ionic radius increases. So we've got to take this and actually connect it to the context given to us, which is the chlorine atom and the chloride ion. So I would again go with the three main ideas, just like for the other question, which is discuss the arrangement of electrons. I've said here that chlorine has an extra electron in its outermost shell. Okay, that's because it had to gain an electron to completely fill the outer shell. How does that arrangement of electrons affect radii? This causes increased repulsion. So there's your first keyword. Between the electrons in the valence shell. Because you're adding that extra electron into the same valence shell, it increases repulsion. So the electrons move further apart. Connected back to the question, this makes the chloride ion have a larger radius than the chlorine atom. Because chlorine and chloride have the same number of protons, or attractive forces of the nucleus remains the same. They have the same number of protons, or you can say effective nuclear charge, just like we read in that in the notes. Nuclear charge is the same. Okay, so the repulsion is the reason that the negative ion has a larger radius than the atom. Okay, so I've tried to keep the same three titles and always end by connecting to the question. So that's question 1b, and that was Roman number 2. Let's look at the last part of that question. The last part of that question is still question 1b. We're still discussing the data for following pairs, but we're actually on Roman number 3 this time. And this time they've given us two atoms, and they are discussing a trend called first ionization energy, which is given to us in kilojoule per mole. Okay, so the first ionization energy for lithium is 526 kilojoule per mole, and for chlorine it is 1200 or 1257 kilojoule per mole, so almost double. Why is that? So that's your answer. Oh, before we look at that, what I would suggest is pull out your resource sheet, pull out the periodic table on the resource sheet. So what is ionization energy? This I've again taken from the Continuing Chemistry, page 79. Ionization energy, and I have asked you to learn this definition, is defined as the energy that's required to remove the least tightly bound electron from each atom of 1 mole of gaseous atom or ions. It is measured in kilojoule per mole. The first ionization energy of an atom is the energy required to remove the first electron from the atom, and the second ionization energy removes the second electron from the ion, etc. Okay, and so sometimes you may need to be able to even write this. This is for neon, but you can write it for the, depending on the context or the element that you are asked for in the question. It's always connected to that. So what is ionization energy? It is energy required to remove an electron from 1 mole of gaseous atom. So if you look at lithium here, lithium is in period 2 and it has 3 as its atomic number. That means it has 3 protons in its nucleus. Whereas chlorine, which is the other atom in that question, is in the 3rd period and it has 17 as its atomic number. That means it has more protons. It has 17 protons in its nucleus, whereas lithium only has 3 protons in its nucleus. So how can we now discuss the data that says that chlorine has a higher first ionization energy than lithium? Why is it more difficult to remove an electron from the outer shell of chlorine than it is to remove one from that of lithium? So let's have a look. I'm trying to keep the same three-step idea to frame your answer. So the first one is, I want you to discuss here. You can't really discuss the arrangement, but I want you to discuss the numbers of protons and electrons. Chlorine has more protons than lithium. So we said 17 protons for chlorine, 3 for lithium. However, so as a result, there's a greater attraction between the nucleus and the outer energy, the outer electrons, which means they are now held more tightly. Why is that so important? Because remember, your ionization energy is how easily can these electrons be removed. But you see that for chlorine, because of the greater attraction between the nucleus, which has 17 protons, and the outer electrons, they are now held more tightly. How does this affect ionization energy? It now becomes harder to remove an electron from an atom of chlorine than lithium. Connected back to the question, so even though the valence electrons of chlorine are in the 3rd energy level, and there is that extra energy level, you may think there may be extra shielding. That extra shielding is not as significant. So I've put that in blue because that's one of your key ideas here. It's not as significant as the effect of the increased nuclear charge. So chlorine has a higher first ionization energy than lithium. So what are your key words here? You have now, you discussed that there's a greater attraction between the nucleus and the outer electrons for chlorine. Yeah, that's your first key idea. So what does it do? It makes it harder to remove an electron. And the third idea is you do acknowledge that there could be that idea of shielding, but it is not as significant as the effect of increased nuclear charge, which means the fact that there are more protons in the nucleus. So there's an increased nuclear charge, and that is more significant than shielding. And hence, connecting always back to the context in the question, chlorine has a higher first energy, ionization energy than lithium. So you see from these 3 answers that I've shown you that you don't really need to write very long answers. It's the key words and the key ideas that are more important. So I hope this was helpful to you.